Hello everybody, it's Mr. Yosef. Today we're going to be graphing rational functions. So as you can see, we have this lovely function h of x equals x squared plus 5x plus 6 over x squared minus 9. So the first step that you always want to do is you want to simplify if possible. Not every function is going to simplify. Sometimes it will be in a form that is already reduced, but here we have h of x, like I said, equals x squared plus 5x plus 6 over x squared minus 9. When I look at the top, that should remind you of a polynomial that you can factor. What same two numbers multiply to, not what same two numbers, but what two numbers multiply to 6 and add to 5. I'm hoping that you see that's x plus 2 and x plus 3. And then on the bottom, we have x squared minus 9, which is a difference of perfect squares. And that's going to give you x minus 3 and x plus 3. Negative 3 times 3 is negative 9, and negative 3 plus 3 is 0. So that's why that works right there. So in our new function that we've simplified, I hope that you can see that x plus 3 and x plus 3 are both the same. So that means something special is going to happen. But before we kind of talk about that, let's go ahead and talk about what makes this function undefined. So when something is undefined, it means like having 0 on the bottom. So if I ever write 1 over 0, or 5 over 0, or x minus 3 over 0, these are all undefined because you cannot divide anything by 0. So when we're looking at this example, we need to look at these two, because these two factors are where something bad is going to happen and make the function undefined. So all we do to find those values is we set them each equal to 0. And when we do that, we get x equals 3 and x equals negative 3. Normally, these are called vertical asymptotes because vertical asymptotes are defined as x values that make the function undefined. However, something weird happens at x plus 3 because you're able to divide it out. So whenever you're able to divide it out, this is no longer a vertical asymptote. This is going to be called a hole. So a hole occurs at x equals negative 3. So I'm going to show you how that looks like on the graph, but for now, we're just going to go at holes and write x equals negative 3 is where a hole occurs. And then this 3 is going to be a vertical asymptote because it doesn't cross out and it still makes the function undefined. So we say x equals 3. So something important to keep in mind is the fact that we now have a new function. Our new function is h of x equals x plus 3 over x minus 3. X plus 2, sorry, over x minus 3. And by new, I don't really mean like something brand new or just something simplified. It's just a different version of what we started with. So remember that we learned to find a horizontal asymptote, we need to look at our powers. When we look at our powers, we see that they're the same. So you look at the number in front and you divide them to give you a horizontal asymptote. And here we didn't have a number in front, but we could easily just put a 1, and 1 divided by 1 is just 1. So we have a horizontal asymptote at y equals 1. So you just have to remember the rules when it comes to horizontal. So I'm going to go ahead and just erase those because we just won't need them later. And what I want to go ahead and take care of right now is remember when I said hole, it happens at a point. So what you do is you just substitute that into our function and you are going to get the y value of our hole, which is negative 1 over 6. So we have a hole happen at negative 3, comma, negative 1, 6. So this is where our hole happens. And we will continue this trend and go ahead and find out some more characteristics of our graph. We are going to find the y-intercept, And to find the y-intercept, you just plug in 0 into your function. So for h of x, we're going to put 0 for x. And remember, h of x just means y. So that means my y-intercept when x is 0 is negative 2/3. And I hope you see that we are kind of gradually just making points on our graph. Like we have -3, -1/6. We know there's a hole. We got 0, -2/3. We know that's our y-intercept. And next, let us find our x-intercept. And for the x-intercept, there's kind of a trick. And the trick is you just take the numerator and you set it equal to 0. Because when you actually do the math and you set h of x equal to 0, the x minus 3 is going to actually go away. So every time the denominator goes away, so you can just set the numerator equal to 0, and that will give you your x-intercept. And we get -2, 0, which is also just another point that we can plot, and we can also write down here. We're going to talk about domain and range, but I just want to make sure that we kind of look at our graph before we do that. So we have found a lot of good information, so I think we should start plotting some of it. I'm going to start erasing stuff to make sure to keep our information clean. It's really easy to get lost in all the math. The first thing I'm going to do is just rewrite what my new function is, which is x plus 2, and then x minus 3, and then erase everything else before we graph. And so just keep in mind, it's just really important to keep your work clean, double check your work, make sure you don't make math mistakes. It's really easy to make mistakes while doing this stuff. So -2, 0 is my x-intercept. 0, -2/3 is like right there. And I have a hole at -3, -1/6, which you can see it's going to be a little difficult to graph. -3, -1/6. And the funny thing about this is when you see what I'm trying to do here, if I said it was -3, -1/6, and that's like right there. But I in my head, I know something is wrong because a rational function normally doesn't look like that. So what I'm going to do right now is I'm going to take a step back and I'm going to check my math right here. And I'm going to go ahead and substitute -3 one more time and check my work and make sure I did it correctly. And as you can see, it's -1 over -1 over -6, which should be a +1/6. So I actually made a mistake here. It should have been +1/6. And you're going to see why later that actually does make a difference, because now I know my hole is like right there. And you're going to see why that makes a big difference later. So sorry for making that mistake. And now we're going to go ahead and graph our vertical and horizontal asymptotes. So my vertical is F3. So that's what we got. And let's go ahead and use a different color for y equals 1, which is right there. And as you can see on this side, I actually have enough points to connect the dots and see the direction that it's going. And that's why I knew I was doing something wrong earlier, because when I had that dot below, it no longer looked like this shape. So just keep in mind that you already kind of have an idea of what rational functions look like. So that is what I have so far. And I'm going to highlight this part. And remember, this is called your hole. So you just kind of symbolize what it is just to make sure that we know it's a hole there. So we are not done yet because we still need to graph the right side of our graph. Depending on how many vertical asymptotes you have, that's how many graphs you're going to have. So if you have one vertical asymptote, you're going to have two graphs. If you have two of them, you're going to have three graphs. So kind of just play with the points and make sure to try them out. So here, I'm going to look to the right of 3. So I'm going to plug in 4. So all you do is you substitute 4 for x, and you get 6 over 1, which is 6. So I know one of my points is 4 comma 6. I can go ahead and pick 5 as a point and do the same thing. I can do 5 plus 2 or 5 minus 3, and I get 7 over 2, which is 3.5. I'm going to write 3.5. And then I already pre-did this point. It's going to be 6 comma 8 thirds. So you kind of just pick some points to get a general idea of what's going on in the graph. When I look at 4, I know that I'm going to have a point at 6. When I look at 5, I know that it's going down. And then 8 over 3 is 2 and 2 thirds, I believe. So all I know is that my graph is going down like that. So we have successfully graphed a rational function. So there's only one last thing to do, and that is to find out what our domain and range. So our domain are all the possible x values. So what I do for my domain is I always start at negative infinity, and I keep going until I run into an x value that I have a problem. So the first time I have a problem is at negative 3, because that's where it's undefined. There's a hole there, so there's still a problem there, so we need to exclude it from our domain. Then we go from negative 3 to our next x value where we run into a problem, and that would be at 3 because there's a vertical asymptote. And then I go from 3 to infinity because I no longer have any issues after that. So that's how you do your domain. It's all your possible x values. And if you're having trouble writing this notation, you could also say all real numbers except at x equals negative 3 and x equals 3. This is better than writing nothing. That shows that you understand what's going on. And then from your range, it's the same thing, except this time you're looking at your y values. You start at the bottom at negative infinity, and you go up, and you should notice that you run into a problem at the y value of the hole, which we found to be 1/6. So we need to exclude 1/6. And then you go from 1/6 to your horizontal asymptote because that's where you can't be 1. So you also put a 1, and then you go from 1 to infinity because we're good as we go above. And you can also write all real numbers except at y equals 1/6 and y equals 1. So that's how you graph a rational function. Once again, sorry for my little math mistake that I made earlier, but I hope you see that through that math mistake that I did not lose faith in what I was doing. I still kind of had an idea of what this graph was going to look like, so I just double checked my math and made it work. Thank you.